So Informix Time Series is a product that was designed specifically to address time series data and the needs of high-volume, time-based applications. This technology was originally rolled out in the financial sectors, and going back about a decade to when we pioneered this technology, the areas in IT that had the highest rate of data coming in tended to be financial, particularly trading floors. And the original time series work done in both Informix and IBM research labs was done in close conjunction with several very large financial institutions that were involved in arbitrage trading. They needed the ability to bring literally what they call ticks, tens of thousands of individual stock ticker movements up a tenth of a point, up 2/10 of a point, down a tenth of a point. They needed to be able to handle huge rates of those from multiple exchanges to find where there were small differences between prices and make trades that were profitable. And so we worked closely with them to build this technology. We deployed it very successfully in the financial area, and we've kind of waited for the world to catch up and other areas of human endeavor to now start generating data at rates that were perhaps a decade ago common only on stock trading and other commodity trading exchanges. And certainly the smart meter market is one. When you look at numbers like 1 million or 3.5 million meters, like the previous example, sending a meter tick, a meter reading event every 15 minutes, you are hitting those same levels of high volume. So what was important in the financial industry and what is also important for the energy and utility markets and smart metering implementations is extremely fast data loading. You have to be able to get all this data in, not with 7-hour lag times, but in real time. You need to have fast access to the data, and you need to be able to run the types of queries that we saw on the previous slide that are very time-centric, from time A to B over a certain amount of time, all of those. And we needed to find a way to provide space savings to the clients using this technology, and we have, because that's another aspect of what working in this arena brings, is large amounts of data. So the more we can store it efficiently and shrink it into less space, the more data can be kept online and the more valuable the resulting applications find the repository to be. To make it usable to the end users, we've developed an extensible toolkit that allows developers to create their own algorithms. So we can't think of everything that a client using time series data will want to do, but we have an open API that allows people to create their own functions to deal with time series data for the particular questions that are unique to their environment. And importantly, those are deployed inside the database and they run as database processes where they inherit all of the good things about the database and are very fast. And finally, the way that we've organized time series data is much closer to how people think about it, and therefore, again, easier for developers and also analysts, people on the business side trying to answer what-if questions. What if we raised the rate for electricity during peak hours or things? Much easier to move those questions from English into a query than it would be if they were having to also sort of deal with the traditional style of organizing time series data in a relational database. So, these are some snapshot pictures that show really the order of magnitude improvements in these key user metrics that we've achieved with Informix time series. And you can see here in a traditional system that the execution times rise, and they rise, in a very nonlinear way as the number of events go up that you're having to do the query across, and also that the load times are far longer. And again, that actually in what we see in many clients today who haven't adopted yet a database that is able to handle the volume and load times is that they tend to go and throw data away. So instead of taking every 15 minutes, which may have been their plan, or every hour, which is another plan, they realize that that's too much and they have to go to once a day or twice a day, which obviously you're losing a lot of benefits that you are working to achieve on the entire smart grid system when you have to do that. And then finally, on this third box on the right-hand side, you see that we have a much more efficient way to store the data, which results in much less disk space being needed for any given amount of data. So I wanted to talk a little bit about how we do this so that you can understand it, because I've been in the database industry as a long time, and all database vendors always say ours is faster or ours is more efficient, but they don't really oftentimes explain to you how they do it. And in this case, it's really some of the basic concepts are fairly simple and familiar to people who work with databases. So one of the things we've done, as I mentioned, is we have created a specific time series data type, and we've also created functions or operators that know how to operate on the data type. And what that means is that the schemas, the way you organize data, are far simpler in Informix time series than they would be in a traditional relational database. And what you see in the top picture here is if you started to put smart meter data into a database, the simplest database that you have, you could do this with. You could put smart meter data into a MySQL or something like that, and you would have one row for every reading of the data, and it would look like this. Now, we've just shown 3 readings for meter 1 on 3 different days, but if you were trying to read the meters every 15 minutes, you would have almost 100 rows generated just on Monday. So it creates huge tables with billions of rows, and of course, when you have huge tables with billions of rows, as you all know, there is only one way that you can get any performance out of overlarge tables, and that's to create indexes. And what you have to do usually is create one index on every column that you need to search on and get values out of. Sometimes maybe you can get by with a primary key being the only index, that would be what you try first, but usually what people find is more indexes are needed to get performance if the queries are based on different columns. And so when you look at the bottom half of this slide, what you see is our very simple way of organizing the data. Because we've created a new data type, time series, and the data type knows, okay, this is something which is going to tick. It's going to give me a value, a value, a value, a value, a value, and that value is always associated with the same, in this case, meter ID. Or if it's a stock, it would be associated with the same stock ticker symbol. So it's a much simpler conceptual model that results in a much more efficient and smaller amount of data and creates very efficient tables. And it's this efficiency which is at the start of driving the performance and space savings. The other thing, obviously, are the functions. We called them methods when we created this, which is kind of a computer geeky term, but they're really the extensions to the SQL language that understand that this time series data type has multiple values in it and that you want to do different things on the values within that single instance, say meter ID 1 in this example. So here's an example. So what you see is that the data itself, by virtue of this organizational scheme, the dark green box on the bottom, it is a little smaller, but there still is a great deal of data and it takes up space. But part of the reason that the total installation is smaller is because we're not having to generate multiple indexes to support having any type of performance. And of course, 2 indexes are shown here, but we have seen in client systems where they have taken this method, which perhaps worked really well with their first sample of 100,000 meters or some synthetic data to simulate 100,000 or 300,000 meters, that it really doesn't scale up at all when they're hitting the 1 million mark. That seems to be kind of a breakover where we see that extending a traditional database does not work. And usually the first thing people do when they hit performance bottlenecks is they go in and look at, could we add some indexes? And they can. But the problem is the indexes on this tend to be pretty large because there's a lot of unique data, and you end up with a lot of data bloat. So this shows a little bit about what the scaling looks like. So the blue lines show the performance that's achieved with just a simple key column index, and you can see that that is unacceptable. In a second example, which is the green box, that scales much better. it actually, it's a little hard to see in the graph, but the query time is about 3x larger for aggregating 80,000 events over the single event query in the first column there. So that's reasonable, but again, you've had to, this was by indexing on every column, and so you've created a huge amount of data and a lot of cost to host all that data to have reasonable performance. And also, as you see, if you extended this 2 or 3 times more to 800,000 and then 8 million, the fact that it's still growing, although in a more linear pace, would likely still result in performance that was not optimum and perhaps not even acceptable to your end users. So this is the serious problem that you have with queries with time series data if you try to force fit it into a typical relational database schema. So let's talk about what's happened in the real world with some of the clients that we've worked with. As you can see, if you're not familiar with them, there's a pretty nice description of Hittelbrand here, who is a technology consultant company very focused on this space that we're working in. And they're right now very active in the United Kingdom, working to scale up their smart metering solution, I believe, to cover a large number of homes in the UK, over 3 million homes. And they want to have a lot of the same benefits that David described in the first part, and they need it to scale up to this large number of homes. And they're looking, as one of their primary benefits, to reduce energy consumption. And, you know, part of the way that we believe, all of us working in this area believe that we can help reduce energy is to give consumers information about when they're spending energy. You know, my wife and I fight over the thermostat, and she likes to turn everything off for the day when she's away, and I come home and turn it on. It'd be nice to see, you know, what does it really cost to leave the air conditioning on when it's 85 out versus flipping it on at 4:30 and trying to cool the house down. Right now, we have really no way to know, but with smart metering, we could. And so there's business benefits for transmission companies. There's business benefits for the retail utility companies, and there's end user benefits. So they're looking to deliver all of those in their system. One of the things they've been able to do then to help end users is provide this kind of dashboard that is easy for people to understand and lets them really look at what their personal energy usage is over a given time period with very detailed information. So you can say, oh, I see, you know, when I cool the house down to 65 degrees to watch basketball games on the weekend, that's really costing a lot of money and using a lot of energy. Interesting, right? And this is stuff that you just can't deliver to customers without not only having smart meters, but having a complete system for handling the data, the MDM application, and the database backend that allows you to retain that for a period of time and sample at a rate that's frequent enough to provide meaningful data, like you see in the graph on the bottom. And also here, we've done some computations of averages so that they can see that this particular house is using quite a bit more energy than their neighbors.